Welcome to this video on the milling process. Okay, so in this video, we are going to go over the motion of mills. So motion, and so that includes linear motion and axial motion. Okay, and so we're also going to go over different components and types of mills. And finally, we're just going to go over, flexibility and limitation of mills. Flexibility, sorry there, and limitations. Okay, so most mills, if we go back through history, mills would move in the the Z direction. The X direction and the Y direction. And as we needed to make more complex parts, or we felt we needed to, we started adding rotation to these axes. So I'm drawing these arrows in the right-hand rule. So just a refresher on the right-hand rule. So this would be the plus direction. This would be all of these are the plus directions and plus axes. So for rotation, the right-hand rule is you have a thumb, and then you have your fingers. Most of us have 4. And you point your thumb in the direction of the axis. This is a real hitchhiker here. And then if you curl your fingers forward, that's the positive direction. So you can practice on this Cartesian coordinate system. And then there's different components to a mill. So I'll just draw that here. You usually have a surface table and a spindle. Just draw the spindle like that with an end mill in it. Okay, so a mill, the cutter rotates. Typically rotates clockwise, and this is called the spindle. And the spindle often moves in the Z direction, but sometimes the table does. So, but definitely the table feeds into the spindle. So here's the X direction, the Y direction, and the Z direction. So you would put your part on here in a vise, really clamped down, fixed very heavily, and then you would feed the part into the rotating cutter, and the cutter is in the spindle. So that's pretty typical of conventional mills, and I'll just go up here to the conventional mills. So now that we know the components of a mill, these are pretty standard. We'll go into the different types of mills. And pretty quickly after that, I'm going to go into the flexibility and limitations. So here we have a conventional mill. This is an older style mill. I'll just draw on the mill here itself the axis. So this table, if you use these hand wheels, you can move the table in the X direction. You can move the table in the Y direction, back and forth. Depending on how this machine is set up, the table either moves up or the spindle moves down. I think most often the table moves up. So you can move the table up in the Z direction. And the spindle will rotate clockwise. So you can see that this it's challenging to produce high precision parts because the operator would have to make the parts just exactly the same every single time, and there's a lot of this method introduces a lot of operator error. So high production is not really a tool that we would, or this isn't a tool we would generally use for high production for complex parts. Maybe simple parts, but even then, probably not the right tool to use now that we have CNC mills. So we'll move down here. We have a CNC machine here, and this is really quite a technological achievement because it's controlled by the computer, and the operator controls the inputs to the computer, but not the actual motion of the machine, generally speaking. So CNC stands for, I'll just draw it right here. CNC stands for computer numeric control. So you're feeding a program into these, and as the computer reads a program, it'll make the cuts in rapid motion and everything like that. And the operator just selects the parameters of the cuts and programs the tooling paths. So now we'll kind of transition into the flexibility of these machines. So here's a machine here that has a part fixtured to the table, directly to the table. So it's not in a vise, it's actually just in the table. And so this machine can move in the X direction. It can move in the Y direction. And the spindle rotates clockwise, and the spindle looks like in this machine that it moves up and down in the Z direction. So this kind of motion, I had an instructor call it like 2.5D. So not quite 3 axis, just 2.5 axes, or 2.5D. And I'm not sure I fully understood that, but I think it's because you don't have access, or you don't have the capability to machine from the bottom side. So really you can just move it side to side and you make all your cuts from the top. So I think that's where you didn't quite want to give the Z a full dimension, I guess. So, but if we look at this machine a little bit closer, we also see that there's a chuck on the side here. So you could load a part, maybe a cylindrical part, or you could load a you could load a fixture that has a cylindrical mount to it, and you could rotate a part, and the machine could move side to side, back and forth, but you could also rotate the part, and the Z direction moves up and down. So this is kind of a similar machine. This looks like an older machine as well, just based on how it's made. But this one, the difference between this machine and this machine here is that the spindle moves side to side, and it's possible that the spindle moves up and down, although it's really hard to tell. And then this would be programmed to rotate. So you could make a pretty unique shape using that method. We'll go to kind of a newer machine here. This machine has capabilities of rotating on this axis. It looks like it can move back and forth like this. It can move in and out like that. And you can start to see how complex of a machine that you can make, or a part that you could make. And it's possible that the spindle moves up and down, or the bed moves up and down, although it's a bit hard to tell. Here's another mill here. I wanted to show this one because it looks like you can load multiple parts in here to make multiple. You can just rotate the spindle and make multiple parts in one program, one CNC program. So this machine, the service table rotates in this direction. It obviously rotates in this direction along this path here. It looks like there's a fairly complex fixture that's bolted to this big circular table here. And then the spindle would either move back and forth and up and down and in and out, or those capabilities would actually be put onto the surface table, and this is just stationary, and all it does is spin. So here's another example with a fairly complex part here. So this is like a component for a turbine engine. So it's like different vanes here. So this can rotate on that axis. The table can move side to side. The table would move back and forth, and the spindle, just knowing what I know about Haas machines, probably moves up and down. And then it's able to rotate about that axis. It doesn't look like it can rotate in this axis, this whole thing, but it probably moves this thing here. This chuck here looks like it could possibly move like that. So again, you can make some really, really complex parts with this style of machine. This example here shows a horizontal mill. I didn't just rotate the picture. This is actually a mill that's coming in from the side. So this table might feed into the spindle. Again, the spindle is rotating like that, and this whole part can probably rotate in that direction and move up and down. It's hard to kind of tell though with a picture like this. And just sort of moving to our last example here is that the spindle is sometimes the main mover and the table doesn't move. So the spindle moves side to side. It looks like it moves in and out. There's some rails here that looks like, it really looks like that the spindle moves in and out like that. And then you can see that the spindle is mounted off of this this part of the machine here, and it looks like it can rotate. So this whole thing can, this whole spindle can rotate about the y-axis here. And then you can see the part can rotate on this axis. And so this is quite a complex machine. This is what's called a 5-axis mill. So you can make really complex parts through this method. Notice that the size of these parts are relatively small. This would be kind of one of the larger parts, it looks like, that you wouldn't be able to lift up with a person. You probably need a machine to lift that up. But, you know, we're not talking about whole airplane wings or bus panels with these parts. Parts that are generally smaller. That maybe you could fit into the trunk of your car or maybe a trunk of your SUV. That sort of size range. Now, there are a few limitations of these machines. So as you get more capabilities, the machines tend to cost more. So you can get CNC mills in the tens of thousands of dollars, all the way up to millions of dollars for machines. And yeah, so just highlighting a recap of what we've gone through here. So we just went through flexibility of these machines. Another important part is that the cutter is rotating and the part is generally fed into the cutter, whereas a lathe in a turning operation, the cutter would be stationary and the part would rotate into the cutter. So that's the main difference between a lathe and a mill. And just sort of the coordinate system here, how these rotate and move along the Cartesian coordinate system. Anyway, that concludes this video. We'll see you in the next video.